ever. Okay, so calculators put away. You don't need them. I don't want you to be tempted to use them because you need to leave it in its simplest form with that square root. Okay, so you need to leave your answer with that root. So to start off here, we're going to kind of derive our rules to use for special right triangles. So I have this square. What do you know about a square? Go ahead, John. There's 4 equal sides, right? What about the angles?
They're all 90 degrees.
They're all 90 degrees. Good. So what I'm going to do, since we're not talking about squares in this chapter, we're talking about right triangles. I'm going to draw in a diagonal from corner to corner here. Okay, I just split this into 2 right triangles. Now when I drew in that diagonal, it split my angle of 90 degrees in half. Okay, so each of these are 45 degrees. Okay, and then I'm just going to label the pieces of my right triangle here. So this side is across from your 90-degree angle. That's your hypotenuse. Okay, and the other 2 sides are congruent. Okay, those are your legs. Okay, so we are specifically looking at, see if my highlighter shows up, this right triangle right here. Okay, so that's the triangle that we are looking at. So what I'm going to do is come up with a rule for a 45, 45, 90 degree right triangle. Now instead of labeling these as legs, I'm going to label one as x. Since they're congruent, what does that have to make the other one? X. Now I'm just going to use the Pythagorean theorem like we were before. Okay, so that's a squared plus b squared equals c squared. So my a and b values are both x. So here I have x squared plus x squared is equal to our c squared value is the hypotenuse. I'm just going to abbreviate hypotenuse and square it. Again, I'm just coming up with a rule. Now, on the left-hand side, I have like terms. I can combine like terms here to get 2x squared. Okay, now to get the hypotenuse by itself, I'm going to take the square root of both sides. Now, when I take the square root of this left-hand side here, if I were to take the square root of 2, I'd get this really long decimal, right? So I'm just going to leave it as the square root of 2. But if I take the square root of x squared, I end up with x. Same thing on the right. If I have the hypotenuse squared and I'm taking the square root of that, I just end up with the hypotenuse. Now remember, I labeled this x value. That was a leg. So I'm going to plug that leg back in. So I have a rule of 2, or the square root of 2 times a leg will equal the hypotenuse of your triangle. Okay, so this is the rule we're going to be using for this type of triangle, and I just wanted to show you how that's derived. Okay, so how they came up with this rule in the first place. Okay, you'll never have to rederive this. Okay, so don't worry about that. But I just wanted to show you where they got this from. Questions before I go on here? We'll do some examples using that rule. Okay, so these are special right triangles. This is a 45, 45, 90. Your legs in your triangle are congruent to each other. So if you're given one of the legs is 4, that means the other is 4. Okay? And then your hypotenuse is equal to a leg times the square root of 2. So again, our rule is hypotenuse is equal to our leg times the square root of 2. So we're going to do some examples using that rule. So if I look at the problems below, we want to find the value of x in each of these. So number 1, the first thing I do is label each of my sides of my triangle. So first I locate the hypotenuse, which is opposite that 90-degree angle. And again, I'm just going to abbreviate. That means the other two sides are your legs. From here, I know this is a 45, 45, 90 triangle. So I know I have to use this rule. I'm just going to plug in what I know into that rule. So I have my hypotenuse. I'll plug in x for hypotenuse. Then I have equals. Plug in your leg. Okay, my leg is 6. And I have the square root of 2. I already found what x equals. That's my answer. Okay, no Pythagorean theorem, nothing like that. Plug in what you know. Find your variable. Questions? Okay, let's look at number 2 then. So again, if I have two congruent sides like this, okay, my legs are both congruent to each other, that means both your angles are also congruent, so they have to be 45. Okay, so this is a 45, 45, 90 right triangle. Okay, so I can use this rule right here. So next I'm going to label my sides. So opposite the 90-degree angle is the hypotenuse. The other two sides are your legs. And again, I'm just going to plug in what I know. So hypotenuse is x. That's equal to your leg is 9 times the square root of 2. And then I have to add on that extra times square root of 2. Okay, if I have square root of 2 times square root of 2, what do I get? The square root of 4, which is 2. So x will be equal to 18. Questions? Do number 3. I'm not trying to trick you. It is really just plugging it in and circle your answer. All right, so what does x equal? What does x equal? 4 square root of 2. Okay, your leg was 4. You have that square root of 2 in your rule. Your hypotenuse was just x. Questions on that one? All right, the last two here are a little bit different. So this side is also supposed to be an x so that you know that they're equal. Okay, so this is a 45, 45, 90-degree triangle. Labeling my sides, I have the hypotenuse over here. My other two are legs. And just like before, I'm going to plug in what I know. So for the hypotenuse this time, I'm going to plug in 5 square root of 2. Okay, that's equal to your leg, which is x, times the square root of 2. So I need x by itself. Okay, to get x by itself, we're going to divide both sides by the square root of 2. Okay, so they cancel on the right. What happens on the left? They cancel as well. So you'll end up with x is just equal to 5. Okay, we'll do another example of that. Number 5. So again, your two legs are equal to each other, so this has to be a 45, 45, 90. Labeling my sides, opposite your right angle is the hypotenuse. The other two are legs. And we'll just plug in what we know to our rule. So for hypotenuse, we have 12. That's equal to, your leg is x times the square root of 2. So again, to get x by itself, you divide by the square root of 2. Now this time you don't have it cancel on the left-hand side. So right now what I have is x is equal to 12 divided by the square root of 2. Now remember when we first started this, I had you simplify square roots. What do I have to do to get that radical out of the denominator? Yes. So I have to multiply by a version of 1. That version of 1 is the square root of 2 over the square root of 2. Here I'm going to multiply straight across. So I have 12 square root of 2 over 2. Okay, this can simplify a little bit further. I have 12 divided by 2 right here to get 6 times the square root of 2. Okay, so that's why I wanted to remind you how to simplify your radicals with that first lesson before. Okay, questions on 45, 45, 90. Those ones are a little easier. All right, so then we're going to move on. We have a different one here. So this is our second special right triangle. Now, just like before, I'm going to show you how they got this rule, okay, that we're going to use. So I have an equilateral triangle. I know we haven't gone over what equilateral triangles and stuff are yet, but if it's an equilateral triangle, all three sides are congruent. Okay, all three sides are equal to each other. All of your angles are also equal. They're all 60 degrees. Okay, but since we've been working with right triangles in this chapter, I'm going to again split this into two right triangles. So I'm going to draw what's called an altitude. Straight down. Okay, that's an altitude. It goes from your angle and is perpendicular to the opposite side to create that 90-degree angle right there. Now when I drew in that altitude, I also split this top angle in half. So instead of 60, both of those angles are now 30. So the triangle that I'm going to be looking at now is this one on the right-hand side here. Okay, so our next rule we're going to come up with are for 30, 60, 90 right triangles. Okay, 30, 60, 90 right triangles. So just like before, I'm going to label each of the sides. So opposite your right angle is your hypotenuse. Now the other two sides I'm not going to label as legs. I'm going to label them something else. So the side opposite your 30-degree angle, okay, the side across from that 30-degree angle, we label that the short side. Okay, and then the side opposite your 60-degree angle, or across from that 60-degree angle, we label that the long side. And yes, I know the hypotenuse is longer than the long side, but the hypotenuse is a specific name already. Okay, so we have short, long, and hypotenuse this time. So just like before, I'm going to use the Pythagorean theorem to get this rule. Now, these two sides are not the same this time. So I'm going to label one as x and the other as y. Okay, so in my Pythagorean theorem here, I have x squared plus y squared is equal to the hypotenuse squared. Now, I can't combine like terms. I can't do much with that. But if I had this altitude dropped in my entire triangle, right, and I labeled this short side as x, that means this side right here is also x. Okay? Now, this entire length across the bottom then, I'd have x plus x, which is 2x. Now, I said before that in an equilateral triangle, all three sides are the same. So how long would my hypotenuse have to be then? If this side is 2x. 2x. So instead of labeling my hypotenuse as hypotenuse, I can change this to 2x. So I have x squared plus y squared is equal to 2x squared. Okay, that 2 and that x are multiplied together, so I can distribute my square to both to get x squared plus y squared is equal to 4x squared. Okay, now I have some like terms that I could combine. So subtracting x squared from both sides, I end up with y squared is equal to 3x squared. And I'll just take the square root then of both sides. So I have y is equal to the square root of 3 times x. So our rule, I labeled the long side as y. So I would have the long side is equal to the square root of 3 times the short side. Okay, so that's one of the rules that we're going to use on the back here. The other rule that I came up with, right, in my triangle was the hypotenuse. All I have to do to get the hypotenuse is take the short side and multiply it by 2. Okay, so that's that second rule. So these rules are a little bit more challenging than the ones on the front. So again, I won't make you redo this. Okay, I won't make you redo this. I just wanted to show you where they get this rule from. So we do have 30, 60, 90 right triangles. These are our two different rules. So we have the hypotenuse is equal to 2 times the short side, and the long side is equal to the short side times the square root of 3. We just found both of those up here. Now they also have the short side for both of these, so if you have to find the short side, you could also take the hypotenuse and divide it by 2. Okay, just solving for the short side. Same thing when you have the long side. You can take the long side and divide it by the square root of 3. Now if you do that, you do have to simplify. Now a good rule of thumb here, you always want to find the short side first. Okay, so if it's not given to you, you need to find the short side first. I blurred all together, but whatever. Okay, so find that short side first. So we are going to do some examples using these rules. So with these ones, you might have multiple steps here. Okay, you'll have to find 2 sides instead of just one like on the front. So number 6, again, first thing I do, look at your angles. Okay, so this is a 60, this is 90, this has to be 30 then. Okay, so I know I'm using these rules on the back here. Next, I label each of my sides. So opposite your right angle is the hypotenuse. Opposite your 30-degree angle, so across from that is your short side. And then opposite the 60-degree angle is the long side. So I'm not given the short side. Okay, that's one of my variables. That means I need to find that one first. So I need to look at my rules that say short side equals. Okay, I have two. Okay, these two say short side equals. I need to decide if I have the hypotenuse or if I have the long side. Well, in my triangle here, I'm given the long side. So that means I need to use this rule right here and just plug in what I know. Okay, so short side is x. That's equal to, our long side is 15 divided by the square root of 3. And then I just need to simplify. Okay, so just like before, multiply by your version of 1 to get 15 times the square root of 3 divided by 3. Simplify that fraction. So your x value is 5 square roots of 3, and that's your short side. Now I still need to find the hypotenuse. Okay, so if I'm looking for the hypotenuse, I need to find the rule that says hypotenuse equals. Okay, that's the upper left one right here. Hypotenuse equals. And I just need to plug in what I know into that rule right there. So your hypotenuse is y equals 2 times our short side was x, but I just found what that was. That's 5 times the square root of 3. So y will just be 10 times the square root of 3. Okay, you do need to find the short side first, because if you're not given the short side, you can't find the hypotenuse and you can't find the long side. So that's why if you're not given the short side, you always need to find it first. Questions? All right, let's look at 7 then. So again, labeling the sides. Always start with labeling the sides. Don't skip that step. Okay, I have my hypotenuse here. Short side is across from the 30-degree angle. If you just want to write S instead of short, you can do that. Opposite 60-degree angle is the long side. So again, I'm not given the short side. That's one of my variables. Okay, which one of my two equations here to find the short side should I use? Top or bottom? Bottom. Okay, I have a number for the long side, so I need to use this bottom rule here. So plugging in what I know, x is the short side. Long side is 12. And then that's divided by the square root of 3. Again, just have to simplify because we don't want that radical in the denominator. So I get 12 square root of 3 over 3. Again, I can simplify my fraction right here to get x is equal to 4 square roots of 3 for that short side. Okay, then I'm also missing y. Which rule out of the 4 should I use to find y? Which one? If it's the hypotenuse, I should use the upper left one here. It says hypotenuse equals. And plug in what I know. So y for hypotenuse, 2 times the short side I just found was that x value, so 4 times the square root of 3. So 2 times 4 is 8, so we have y equals 8 times the square root of 3 for that hypotenuse. Questions? How do you feel about this side? Are you feeling okay? Yeah? All right, I want you to just do number 8 for me really quick. Okay, do number 8 for me really quick, and I'll pass out your assignment here. If you already did number 8, try number 9. Okay, so those of you who are done with 8, you should have x is equal to 5 and y is equal to 5 times the square root of 3. Okay, you were given the hypotenuse for that one, so finding the short side, you'd use this upper one right here. 9, if you did 9, you should get x is equal to 42 and y is equal to 21 times the square root of 3. Okay, and then I'm just going to explain why some right triangles are considered special. So I've been calling these special right triangles, right? So before, in section 8.2, we used the Pythagorean theorem to find side lengths, correct? Yes? For that, you had to use a calculator. Okay, you had to use a calculator to help you find those. With these ones, they're considered special because you don't need to use a calculator. Okay, so they are considered special because you can solve for the sides without the use of a calculator. Okay, any questions?